Okay, let's go. So, hello everyone, I'm Frank, and as Limone was saying before, I'm a proud Urbe member, one of the first one, and a Web3 developer. And today we will start with Solidity smart contract development for this Kickstarter-like application. Okay, so why? Because when we were thinking about this Urbe Campus, we wanted to develop during the campus an application that can be a good submission for an hackathon. Okay, so for example, for ETHWarsaw. And why a crowdfunding application? Because it's pretty easy to understand, because a Web3 version is very similar to the Web2 classic version of a crowdfunding application, and also because it's easy, the smart contract part, okay, of this application, and so it's easy and is a good way to understand and to learn more about Solidity and smart contract development. So let's start with Kickstarter. Okay, we want to replicate something similar to this one. Okay, so if we go to Kickstarter, we can see that we have different projects that basically are different campaigns. And if I click on a specific campaign, I can see here a button to donate some money to this campaign. I can see the number of donors. I can see how much money this campaign has reached. And I can see, for example, how many days are left for the end, basically, of this campaign, okay? And then here, I can see some metadata, so a description of this project, so text. And here, I can see also some let's say some perks that I can choose when I donate. Okay, so for example, I can choose to donate €7 in order to buy this product, or I can choose this one for €15, or I can choose this one for €25, and so on, or I can decide to donate without taking anything back. Okay, so if this is clear, what we are going to do is to try to replicate, in an easier way, of course, Kickstarter, okay, for Web3. What does it mean for Web3? It means that basically we will have an application where people can donate in USDC on Base network. They can donate for one or multiple campaigns. And they can receive back, for example, an NFT representing their positions or their donation, so that the NFT can be transferred after the donation. So let's say I donate for a specific product on a campaign, I receive back an NFT, and maybe I can trade my position on a, let's say, an NFT marketplace or whatever. So this is the main idea. So today we will start with the smart contract part, while tomorrow Paolo will try to replicate a little bit this front end. So is everything clear? Okay. Okay, in order to start with the smart contract development, we need Ardat. So our smart contract project will be powered by Ardat. So, do you know Ardat? There's someone that doesn't know Ardat or never use Ardat? Okay. Okay, so in a few words, Ardat is a very simple and familiar framework to write, compile, test, and deploy smart contracts, Solidity smart contracts, okay? And the cool thing about Ardat is that it's easy to use. All the test, deployment, and whatever is written in TypeScript or JavaScript, while the smart contracts, of course, are in Solidity. And the cool thing is that there is a huge community behind Ardat, and there are a lot of plugins developed by the community that you can import and use in your project, okay? So even if something is not supported by design, by Hardhat, we have a lot of plugins developed by the community that we can take and use in our project. Okay, so let's start, and I think while using Hardhat, it will be very clear and very easy to use. So the first thing is I have, in this case it's Cursor, but I can use Visual Studio or whatever editor. The first thing to do is to create an empty folder. So in this case, Urbe Campus 2024. Open the terminal, and the first thing to do is to install Hardhat. Okay, you can install with npm, or you can install it with yarn, whatever. So I already have Hardhat installed. If you have to install Hardhat, please do it right now. After we have Hardhat installed, we can start creating an Hardhat project. How we can create an Hardhat project? With this simple command here. So npx hardhat init. Okay. Now Hardhat will ask us what kind of project to create. So a JavaScript one, a TypeScript one, a TypeScript with VM, because by default it uses ethers, or an empty Hardhat, so without VM or ethers. So in this case, I will use TypeScript. And I suggest you to use TypeScript. In this case, I will use ethers, but it's pretty the same if we choose to use VM. So let's click on this. Hardhat project root, in this case, is my folder, so Urbe Campus 2024. So now it asks if we want to add a git ignore that can be useful when we push on GitHub. So if we say yes, we already have a git ignore created by Hardhat, so we don't have to create later a git ignore for our GitHub repo. Let's say yes, and now Hardhat asks us if we want to install all the dependencies needed to start an Hardhat project, and let's type yes. So right now it's basically is installing all the dependencies, all the things that are needed to compile a smart contract code, but also to test it, to deploy, and so on. So let's wait a little bit. Yeah, some word. Okay, so we successfully created an Hardhat project, and if you do it, you should see a contracts folder, an ignition folder, along with some node modules that were installed when we installed the dependencies before. And also we have an Hardhat config TypeScript file that we will see later, okay? So once we have our Hardhat project initiated, we can start basically to use Hardhat. So these are, let's see. Okay, these here available tasks are some relevant commands that you should know if you want to develop using Hardhat, basically. Okay, the first command, that one of the most useful, is npx hardhat compile. Okay, this command is used to compile the contracts under the folder contracts here. Okay, so in this case, under the folder contracts, we can find lock.sol contract that is basically the sample smart contract that is created when we initialize the first time Hardhat. Okay. If we type, as said before, npx hardhat compile, we can compile our contracts. Okay, it means that if we have some errors in our smart contract, the compilation, of course, will fail, and it will tell us the problems that we are facing while compiling the contracts. Another useful command that we can use in RDAT is npx RDAT-test. Okay, in this case, we are basically launching the test under the folder test. So in this case, it's this lock.typescript file. And we will see later other useful commands, okay? But right now, just to start, the most important one is npx RDAT-compile. Okay. I already compiled the lock.sol smart contract, so if I try to compile another time, it will say nothing to compile, no need to generate any newer typings, because I already successfully compiled the smart contract, okay? So now let's clear a little bit our terminal, and we can go deeper and start with our smart contracts. So do you have any question? Any question about our RDAT, initialization, whatever? Everything clear? Okay. So that's cool, and I think we can start with the development of our Kickstarter-like smart contract application. Okay. So the first thing to do is to create another contract here under the folder contracts that we can call, let's say, campaign. So, and we can delete the lock one, okay? So right now we have the campaign.salt contract that is an empty smart contract, and here we can start typing and writing some code. Okay, the first thing to do is to write this line that is basically the license that we are going to use in this smart contract. So this is not mandatory, but if we don't select, if we don't write a license, we will have some warning. So it's always better to specify a license for the smart contract. So in this case, it's the MIT open source license. Okay. Then the first thing to do in order to create our smart contract is to type pragma solidity and the version that we want to use of the Solidity compiler. Okay. So in this case, we can simply use the 0.8.0. That is a relatively old version of the compiler, but is very solid, let's say, and is good enough for what we have to do right now. Okay, so two things: the license and the version of the Solidity compiler. Okay. Now we can start to create a contract. Okay, so contract campaign. And then we create an empty contract right now, okay? So contract is the keyword in order to define a smart contract in Solidity, and then we have the name of the smart contract. So in this case, it's campaign, okay? So in this case, my file campaign.sol has the same name of my contract within the code, but I can also write a different name. Okay, so in this case, just because it's easier, we can choose the same name for the file of the smart contract and for the contract name itself. Okay, so we have a compiler version, we have our name, and we have our license, and right now we can start developing our smart contract. Okay, now I want to think with you a little bit of how our contract should work, taking as a reference Kickstarter. Okay. So we said that we have different campaigns. So here we can explore different products where each product is a different campaign, okay? So we have different campaign. Each campaign has some parameters, okay, that are dynamic. So each campaign has some amounts of funds received, as a number of donors, some days left for the end of the campaign, and so on, okay? So we will start writing our smart contract defining what is a campaign, okay? Then, of course, we can modify it later if we need, but let's start with some basics, okay? So the first thing, and the first thing that I wanna do is to define a struct called campaign, okay? This campaign struct will have some, okay, yeah, of course I can't, let's call it CP, okay? CP is campaign, okay? We will use CP in all our code to say basically campaign, okay? So, what is a campaign? A campaign has, in my opinion, as an admin address, so a wallet address that is capable to manage the campaign. So, for example, in Kickstarter, we should find who is the creator of this campaign in some way. Okay, yeah, for example, here. So, in this case, this campaign on Kickstarter was created by this Kudos Editore, that is an Italian publishing house. So, let's try to replicate it. So, we will have an admin in our struct. We will have some metadata, so basically this text that can be a string, and we will call it CP metadata, okay? This metadata is a string. I will explain it better later, but basically we will save on IPFS, that is a distributed storage. We will save all the metadata that we can find in a campaign page. And this string, CP metadata, is basically only the reference of the URL of our metadata on IPFS, but we will see it later. For now, it's enough to understand that we will have some metadata represented by a string, okay? Then, what we have here? So, we have a goal, for sure. I'm pretty sure that we have a goal some way. Let's see. Where we can find the goal. Let's see another campaign. Okay, here, this is Italian, but it says that is all or nothing, okay? So on Kickstarter, each campaign can start only if the goal set by the admin is reached, okay? So, for example, if this campaign was set with a goal of, I don't know, 100k euro, it means that the admin of the campaign can take that money, and so the campaign can successfully end only if this campaign reaches this 100k euro, for example, okay? So we will follow the same pattern, okay? So we will have a goal to reach in our campaign struct, okay? This is perfect target amount. Let's call it target amount. So this is basically, let's write some comments. So this is the admin address that can manage the campaign. This is the metadata of the campaign that we will save, we will store on IPFS. And this is the target amount of the campaign to reach. So if we don't reach this goal, the campaign can't start and the donors can take back their money. Okay, this is the logic that we want to implement. Okay, so what else we have in a campaign? Let's see.
So I have a question.
Yeah.
About the first address. It includes name, everything, or we need to...
It's just a 0x address. So it's an Ethereum address. Okay? It's an address that we will see it later, but that can call specific function in our smart contract in order to manage a campaign. Okay, so for example, let's make an example. The admin can pause the campaign. Even on Kickstarter, an admin can pause a campaign. Okay, for example, if a campaign admin thinks that it doesn't want anymore to have this campaign running, okay, he can pause the campaign. And when the campaign is paused, all the donors can take back their money. Okay, so for example, in our smart contract, we will have a pause function that will be called only by the admin, so that by this address admin. Or for example, or maybe he can have other privileges, so he can call other function in our smart contract. Okay. So, do you have any question? We are basically trying to define what is a campaign, okay? Taking this as reference and put it back in our smart contract. So, we said that our campaign has an admin, a metadata, and a target amount. Then, for sure, our campaign, we will have some a start date, okay? Because I can create a campaign that can start later, maybe, okay? So we can call it CP start, okay? This will be CP target amount, and this will be CP admin, okay? And this is the start time of the campaign, perfect. Then, of course, we will have a campaign end. So our campaign should end some way. Okay. So we said that our target amount is the amount of USDC in this case that we have to reach in order to successfully close a campaign. While this CP end is a parameter that basically will tell donors if they can donate or no, because if the CPN is reached, it means that donors can't donate anymore. Okay. What else? Any idea?
So about the sorry for the CP metadata includes image,
yeah.
frames, everything.
Yeah, all the metadata that we can see on a Kickstarter page. So image, this text here, description.
For example,
what?
Short videos or something.
Maybe, yeah. Yeah. Okay. What else do you think should be in a campaign?
Should we include the kind of fail part? For example, if it doesn't reach this amount, we will be refund. So, you will include for this one also?
Yeah, this is not something that we have to define within a struct, but we have to define in the logic of the function in the smart contract. Okay, so a struct is just so when we write a struct, it means that we are taking all these parameters that we are defining here. Okay, so a campaign is defined with all these parameters together. Okay, then we will use this campaign struct, so these parameters, within a business logic, of course, that we are going to implement in the smart contract. So, for example, do you think that we should have the donors? Should we track the donors, for example, of a campaign? I would say yes. But I will teach you a trick to better manage the donors part, okay, in order to save gas, to be more efficient, and so on. What else? So, for example, we don't have the amount donated so far. Okay? We don't have it. Other parameters, let's say. So, this is the donors. This is the amount collected. This is the hours left. This is the button to donate. These are just metadata, and this is a way to buy this product, basically. Okay, so it feels like we have all the parameters needed in order to define a campaign. Okay, now we can start to use these campaigns in some way. Okay, so let's start. Okay, there is something that is missed right now. For example, I said at the beginning that we want to accept USDC only. Okay, so we should define what is USDC. Okay, so USDC is defined by an address. Okay, that we can put public, and we call it USDC address. Okay, so in this way we can define what is USDC. Okay, then, so this is a struct, while these are storage variables. Okay, I want to define also is the campaign is active, so is the campaign started or not. And also I want to define if the campaign is ended or not. Okay, so I can, let's put a comment and write campaign status. Okay, so this Boolean value will be true when the CP start is reached, while this Boolean will be true, so is ended is true, if this CP end is reached. Okay, so this is the USDC token address on base network. Okay. Okay, let's start. So, the first thing that we need is a way to initialize our campaign with these parameters, okay? Because right now, these are just empty parameters, okay? So, if we check these parameters right now, we will see that USDC address is empty, is active is false, because all the Boolean parameters in Solidity are false by default. So if not initialized as true, will always be false. So this will be false. This will be false. This will be empty. This will be empty. Everything will be empty. So we need a way to initialize our campaign parameters. How can we do it? Let's define a function that is called init. Okay. What we have to define in this init function? We have to define these parameters. So, for example, we have to define the address, the USDC address. We have to define, for example, the address of the CP admin. We have to define the string of the metadata. We need the keyword memory for a string in Solidity, okay? So what does it mean? It means that for memory, we have to specify what kind of memory we want to use, okay? Because in Solidity, we have three different kinds of memory. We have memory, we have storage, and we have cold data, okay? So the storage one is a persistent memory, okay? While the memory and call data are temporary memory, okay? In this case, we are defining this CP metadata as memory because later we are going to override this parameter, that is a storage one, with this memory one, okay? So we need just temporary memory for string because we are going to override the storage one. Then let's put basically all these parameters, so the CP target amount, the CP start, and the CP end, okay? And we can put this function as public. Do you know the difference in visibility for functions in Solidity? So we have different kind of visibility in Solidity. We have four kind of visibility. We have public, we have private, we have external, and we have internal. Okay. So in this case, so basically internal is quite easy because it means that an internal function can only be called by another function of our smart contract. Okay. External means that a function can only be called by an external smart contract or an external operator. Okay. So external from this smart contract. Okay. Public is basically it can be called by anyone. So it means that it can be called by external operators or internal ones, whatever. In this case, we need public because we need to initialize from the external. We need to initialize our smart contract. Okay. So who will initialize this contract? Basically, the admin that will create the campaign. Okay, so the admin will create a campaign and it will initialize the campaign according to its needs, basically. Okay, so how can we initialize some parameters in a smart contract? We wrote an init function, and then it's super simple. We need to override basically our parameter in storage with the parameters that are inputs in our function, okay? So in this case, USDC address, so this one will be equal to underscore USDC address. CP admin, the same thing, metadata, target amount, start, and end. Okay. As we can see, we have some errors because in Solidity we can't write directly on a parameters if this parameters is part of a struct. Okay. So, for example, we can successfully override USDC address because USDC address is a storage variable outside from our campaign struct. While all these parameters are within our campaign struct, okay? So basically now we have two options. The first one is to take these parameters and make these parameters as storage variables. So, for example, address CP admin can be parameters within the struct, or can be a variable in the storage. Okay. Or we can initialize the struct, basically. So, the best thing to do in this case is to write all the parameters that we previously put in the struct as a storage variables, okay? I will explain why. So in order to campaign details, and then we have address public, cpadmin. We have string public, that is the CP metadata. We have wint 256, that is the target amount. We have the CP start, and we have the CP end. Okay, and we can basically delete all these things. Okay, why? So why why I should choose a struct, and why I should decide to have all the parameters as storage variables? Okay, so with the design that I thought when thinking about this campus, in my idea, each campaign will be represented by a separate smart contract. Okay, so when I create a Kickstarter-like campaign, I will automatically deploy a new smart contract. Okay, for a campaign. Okay, so in this case, this campaign.sol contract will basically store just one campaign. Okay, if we need to have multiple campaigns, okay, because we are building a platform for creating campaigns, so for sure we will have multiple campaigns. We can do it in two different ways, maybe three, but let's say two. So the first one is to define a campaign struct, as said before, and then have a mapping that will map each campaign to a different ED, okay? So that we can store a lot of campaigns, multiple campaigns within the same smart contract, and then each campaign will be defined by a unique identifier, okay? The alternative, that is more elegant, let's say, and a little bit complex, and is my choice, is to use a factory. Do you know what is a factory? So basically a factory is a smart contract that is capable to deploy other contracts. So in particular, is a smart contract that is capable to clone a smart contract and to deploy different clones of the same contract, okay? So what does it mean? It means that we are going to define a campaign smart contract, and then we will have a factory that will deploy multiple times our campaign smart contract, one for each new campaign created on our platform, okay? In this way, having one smart contract for one campaign, we can define all our parameters defining a campaign within storage variables, okay? Because what will happen is that I will deploy, so our factory will deploy multiple campaign contracts, and each campaign contract will be initialized with different campaign parameters. So it means that I create my own campaign with these parameters, basically. Then another person can create another campaigns with different parameters, and so on, okay? Is it clear, the design? Because it's a little bit complex, but if you understand the factory approach, it can be really powerful and pretty useful for your DApp development. So I repeat another time. We will have basically two smart contracts. The first one is the campaign.sol, containing, made of all the business logic and all the parameters for a single campaign. And then we will have a new smart contract called campaign factory that basically will clone our campaign.sol contract, and it will deploy multiple times our campaign contract, one for each campaign created on our platform. So let's continue with the development of our contract. So right now we are in the function init. So this function is used to initialize storage variables of our campaign. So basically we have to override all the parameters defining a campaign. So USDC address, CP admin, CP metadata, CP target amount, CP start, CP end. Okay, this. Okay. While these parameters, that is the status, we don't have to initialize the status because the status will depend on the status of our smart contract. Is it clear? Okay. So now we have our smart contract that can be initialized. So let's put a comment. A comment here. Initialize the campaign. Okay. Now, we have to create a campaign, or maybe the admin of the campaign, that is the CP admin, should create a campaign, okay? So we need basically a function to create a campaign. We need a function to actually create our campaign. Will be external because this function will be called by the admin of the campaign when creating it. Okay. And okay, let's make let's explain a step before the create campaign. So we previously said that a campaign is defined by these parameters, okay, that are initialized by when deploying a new smart contract. Okay, these parameters define a campaign. So what is a campaign? A campaign is made of these parameters. So when we create a campaign, basically we need to define the parameters to we need to define the parameters for a campaign. Okay. So what we can do here is a little trick that is this one. So let's create a function called underscore create campaign with internal visibility. Okay. So when we use the underscore before a function name, it means that the visibility is usually internal or private. Okay. So create a campaign, and we will define the same parameters defined in the init function. Okay, with the same exact input parameters. Okay. And the trick here is that we can have an external function called createCampaign, accepting, of course, all the parameters needed in order to define a campaign. And then we can simply call the underscore createCampaign function. So it means that this function will take these input parameters and it will call this function, that is the underscore createCampaign, and the underscore createCampaign will initialize the parameters needed for a campaign. Okay? At this point, we can simply delete these parameters here and just call the createCampaign. Okay, so what happens here? Basically, we have an initialize function, and then we have an initialize function that will call the underscore create campaign, and then an external create campaign that will call the underscore create campaign. So what does it mean? It means that if we don't initialize the smart contract when deploying it through the init function, we can later initialize this contract using the create campaign. So we have basically a double choice here. It's basically the same. But this will be called when deploying the contract, while this can be called at a later stage. Okay. Now, we have to be sure that we can create just one campaign for each smart contract, because otherwise we can override existing campaign parameters. Okay? How can we do it? We can simply create another Boolean value that will be called isInitialized. Okay? And when we call the underscore create campaign, we can put this isInitialized parameter as true. Okay? In this way, we know that the first time that we call the underscore create campaign, we are going to put this initialized parameter as true. And now we need a requirement. So we need that isInitialized is false in order to call this function. Okay? While, because otherwise we can override the parameters. While what happens here is that the first time that we call the underscore create campaign using the init or using the create campaign, the require is okay, because isInitialized will be false, because by design, as said before, all the Boolean parameters are false. And then we put it as true. So the second time that we try to call the underscore create campaign, this requirement will not be okay, because we need that isInitialized is false, but we will have as an isInitialized true. And so our function will revert with an error, and the error will be this one, campaign already initialized. Now, just to be clearer, we can put okay. So usually when we write a contract, we have the private and internal function at the end of the code. Okay. So first the external and public, and then the private and internal. So we can create a comment function to create a campaign, or maybe internal function to create a campaign used by create campaign function or init function. So basically right now we are able to create a campaign. Any questions? Is it clear? Okay. So we said that the admin can create a campaign, but the admin can also pause the campaign. Okay. So let's create a pause function. So function to pause the campaign. So we will have a pause campaign pause campaign function that will be external. Okay. Who can call this function? The campaign admin. Oh. Only the campaign admin, right? Okay. So we need a requirement. Okay. We need that the message sender is equal to the parameter cpadmin that we previously defined here. So this requirement is okay. Or if we don't want to use a requirement, we can use a modifier. Okay. What is a modifier? So basically, a modifier is something that we can plug on each function, and each function that is declared with a modifier should follow this requirement in order to be called. Okay. So what does it mean? It means that if we copy the only admin modifier and we put the only admin modifier here, and we delete, or maybe we can comment this requirement, the result will be the same. So if this function is an only admin function, it means that this function can only be called if the message sender, so the address that is calling the function, is equals to the cpadmin. Okay. In this way, using a modifier, we can use the same requirement on different function in our smart contract without rewriting the same requirement multiple times. So basically, we can avoid to rewrite the same things different times. Okay, so we can delete these requirements, and so we will have a modifier that is only admin for the post campaign function. This one? 21st. This one? No, this one is just a syntax rule that you have to follow when writing modifier. So the modifier ends with the underscore and the comma in this way.
It's not meaning like make code after this like this dash when this.
You mean this one?
Yeah.
Yeah. What is the question?
Oh, it's like it's meaning like go code down and run function with the original statements.
Yeah. Yeah.
But still with modifier.
Yeah. So the modifier will be checked when calling the function. Okay. Yeah. So before executing the code that we will put here, okay, some code here, we are sure that this modifier will check the requirement before calling it. Okay. So what the post campaign function does? Pause the campaign, yeah. So we can, for example, create another Boolean value that is called isPaused, and the post campaign just isPaused as true. Just set the isPaused parameter as true. But before pausing the campaign, we should check that the campaign has started, because we can pause a campaign only if it previously started. Okay, so we need a requirement that is active campaign, because otherwise we will have an error. Campaign is not active. Okay. We didn't define what is active right now. We will define it later. Okay. So right now we have a create campaign function and a post campaign function. So we can go deeper a little bit in the underscore create campaign, because right now we are not checking anything basically on the parameters that we take in order to create a campaign. For example, the only thing that we check is if the campaign has already been initialized, but it's not enough, okay? Because, for example, we should check that the USDC address is different from address 0. So the underscore USDC address that we are passing in the underscore create campaign is actually populated address, okay? It's different from an empty address, basically. So this is the first check. Then we should check the same thing on the campaign admin. So a campaign admin should be a valid and populated address, okay? Because otherwise, if this is not populated right now correctly, so for example, if this address is empty, so address 0, basically, we will have troubles later, for example, in the modifier, because no one will be able to call the create or post campaign, because no one controls address 0. So the CP admin should be an address, okay? Another thing is that we need, for example, a target amount that is greater than 0, because at least 1 should be our goal to reach. Then this is a good suggestion, because we need also a CP start. So CP start is the moment when our campaign will start, and our start point should be in the future, okay? So in the future, it means that it should be greater than the block.timestamp, because the block.timestamp in Solidity returns the exact moment, okay, this exact moment. So if we create a requirement that is CP start greater than the block timestamp, we are sure that we are creating a campaign with a start point that is in the future. And at the same time, we need that the end of the campaign is greater than the start, of course, okay? So if we write CP end greater than CP start, we are also sure that the CP end is in the future, because CP start is greater than block timestamp and CP end is greater than CP start, okay? So right now, basically, we are validating the parameters that we are passing in the create campaign underscore create campaign function. So in this way, we are sure that we are creating a valid campaign, basically. Okay. Yeah.
So could you say again why we're using bracket 0, address bracket 0?
So address 0 is this one, 0x,
Okay.
all the 0, okay. So in Solidity, when we write different from address 0, it means that the address is actually an address, so it's populated.
It will be born our mind.
Yeah, yeah. Okay. And also, the address 0 identifies Ether, ETH, on Ethereum, and all the native coins on different chains. So when we says that USDC address should be different from address 0, we are saying that the address should be populated and our address should be different from it. Okay, should be an ERC20 token, basically.
We cannot pass multiple conditions
donations in return. So we are using.
No, no, no. We need different requirements. Okay, so we validated basically the parameters in order to create a campaign. We validated and we wrote the post-campaign function. So now we can start to write, for example, the donation logic, okay? How we can donate, okay? So the create and pose are CP admin function, okay? While the we now are going to create a donate function that is donor functions, okay? So for example, I'm thinking that when we define the campaign parameters, we didn't set, for example, a minimum for a donation or a max, okay? So in this way, right now, we can donate whatever we want, basically, from 1 to infinite. So we can decide to create here some parameters to manage this aspect of our donation, or maybe not. So in this case, just to keep it simple, we will not define some minimum, maximum donation parameters. But if we want to do, you can pretty easily do it. So let's write a donate function. Okay. So this function will be used by donors of our campaigns. So the first thing is that we have to define how much we want to donate, okay? So it's a int because it's a number, and we can call it amount, simply amount. Okay, and we can create a requirement that the amount must be the amount must be greater than 0, because we can't donate 0, of course. Okay, and then in our business logic, we can donate to a campaign only if the campaign has started, okay? And only if our campaign has not been paused, and only if our campaign has not ended. Okay? Makes sense, I think. So these are good suggestions. So requirement is active. Is not paused, and the last one is that the block.timestamp, so this exact moment, is less than the CP end that we previously defined. Okay? In this way, we can be sure that our campaign has started, our campaign has not been paused, and our campaign has not ended. Okay? So the next thing to do is to actually transfer USDC from the donor wallet to this campaign smart contract. Okay. How can we do it? So we need to define. So do you know what is an ERC20?
Yeah.
Okay. No, so an ERC20 is basically a token that follows a specific standard defined by the ERC20 standard. Okay, so it means that all the existing tokens following the ERC20 standard will have some specific functions. Okay, so we already know that an ERC20 has, for example, the transfer function, the transfer from function, the approve function, and so on and so on. Okay. USDC on base is a standard ERC20, and so in order to write a transfer in Solidity, we have to use the interface of an ERC20 that is defined by the iERC20 keyword. The iERC20 interface wants an address, so the address of the ERC20 token that we want to interact with. In this case, what is the ERC20? Is this USDC address that we previously defined. So we copy this variable name, we put it here. So in this way, we know that we are interacting with an ERC20 through its interface, that is the iERC20, and in particular, we are interacting with this ERC20, that is this address defined by the variable USDC address. Okay, now we can access the ERC20 functions. Okay, in this case, how can we do it? It's just dot, and then the name of the function on the ERC20 that we want to use. In this case, is the transfer from. Okay, the transfer from function. Now I will explain what is the transfer from function. It's basically a function of the ERC20 that is used to transfer some amount of tokens defined by the amount variable from the message sender, so the address who is calling this function, to a recipient address that in this case is address this, so the address of this smart contract. Okay, so it means the address of this campaign contract.
Also, like, why we not put a dash to amount of, like, because when we putting like some variables to function, we're putting a dash sign to and after the name of function, like why we not put dash to amount?
The underscore, you mean?
Yeah. Oh, sorry, underscore.
Because in this case, this is an external function.
Okay.
So this is okay. So yeah, just to be sure that we are on the same page, we can delete the underscore from the previous. Now let's make it in this way. So we have the underscore here because this is the initialization, and so we can't use the same name cpadmin and cpadmin. So here we need the underscore just to say that are two different variables. But if you want, we can delete the underscore here, because this is an external function. It's not an internal or private, or it's not the initialization. So let's delete the underscore here and here. No, roll back. We can do it okay. because otherwise we will use the same name for.
Okay, so it was only a question.
No, it's a good question. So basically, if we define some variables in the storage, then we can't use the same name for inputs.
Yeah,
Okay. So if you want to delete the underscore, you should call these parameters in a different way.
okay.
But right now, let's stay let's stay here. Okay, so we were talking about the transfer from function of the ERC20 standard. So, do you know OpenZeppelin?
Yeah.
Okay, cool. So basically, OpenZeppelin is an open source library for smart contract solidity code, and is basically OpenZeppelin is the standard for smart contract development. Okay, so for example, OpenZeppelin defines what is an ERC20 tokens, what is an ERC721, so NFT tokens, along with other utility libraries that are used in the Solidity development. Okay, so basically, OpenZeppelin is the main reference that you should use when developing some contract. Okay, so for example, OpenZeppelin has developed the ERC20 standard code, and we can see here in the docs.openzeppelin website, we can see how the OpenZeppelin ERC20 standard works. And if we go on API ERC20, we can check all the functions that are inside the ERC20 token. Okay. So this is pretty useful. I suggest you to study a little bit the OpenZeppelin contracts, because it's the industry standard basically. So, in order to interact with an ERC20, we need the interface, okay? This one, IRC20. Then we need the transfer from function, okay? Let's click on transfer from. Transfer from function moves amount tokens from to using the allowance mechanism. Amount is then deducted from the caller's allowance. Returns a Boolean value indicating whether the operation succeeded, and also emit a transfer event. Okay, so the transfer from function should be called passing three different parameters. That is the from, so basically the address holding the token, the to, that is the recipient address of the transfer, and the amount, that is the amount of token that we are going to transfer. Okay, the cool thing about the transfer from function is that the transfer from function can be called by the holder of the token or by an external address. Okay, if called by an external address, you need to be sure that the address holding the token has previously approved the spending of that amount of tokens. Okay, do you know what is approve? How an approve works? So basically, in the ERC20 token standard, we have an allowance parameter. Okay, is this one. So the allowance parameter takes two input parameters. That is the owner, that is basically the token holder, and the spender. Okay, so a third-party address that can spend some tokens on behalf of the holder. Okay, so this function allowance returns a wint that is basically a number, and it says the amount of token that the spender address can spend on behalf of the owner. Okay, how we can increase or decrease this amount using the approve functions. Spender amount. So owner is the owner holding the tokens. Spender is the address that can spend the amount of tokens defined by the approve. Okay. So let's go back to our code. I wrote IRC20 of USDC address, so we are interacting with this IRC20, and we are calling the transfer from function, passing as from parameters, because if we take the transfer from, it wants from, and in this case it's message sender, so the address calling this function, the donate function, the to, so the recipient, that in this case is this address, so the smart contract campaign address, and the amount, defined by the amount parameters. Okay. What happens if the address calling this function, so the message sender, has not enough funds in order to donate this amount? So for example, let's say I have only 10 USDC, but I'm calling this function and I'm passing as an input 100 USDC. It will fail. So the function will fail because this transfer from returns a Boolean value indicating whether the operation succeeded. So this function returns a Boolean that can be true or false. True if the transfer was good, or false if there was a problem such as not enough balance and so on. So we can write this cool thing that is a requirement. Require RC20 transfer from. Okay, what does it mean? It means that we need true. So we need that this function returns true. If this function returns false, this requirement will not be satisfied and we will have an error that is transfer failed. Okay, so right now, as you can see, we have an error here that is undeclared identifier. Why? Because this smart contract, this campaign contract, doesn't know what is IRC20, okay? Because IRC20 is not something in the that is implemented by design in Solidity, okay? IRC20 is just an interface for a standard that has been developed by developers. So, for example, OpenZeppelin has the IRC20 standard contract, okay? So it's basically an external dependency in this case, okay? We need to import in some way this IRC20 interface in order to interact with an IRC20 contract. How can we do it? It's super simple. We need to import the OpenZeppelin IRC20 interface. This one. So if we go here in OpenZeppelin documentation, you can see an import interface of the IRC20 standard as defined by the EAP. So if we copy this line of code, this import, and we put it here, okay, we don't have any more the error. Because right now, we are importing this interface, IRC20, that we are using here. Okay? Okay, now we have another error that is file import callback not supported. Okay, it means that we didn't install the OpenZeppelin dependency, okay, this dependency that we want to use. We need to install this dependency in our project, in our r.dat project. How can we do it? Super simple. We need this command, npm install OpenZeppelin contracts. In this way, in our packages, we will add the OpenZeppelin dependency. So if we put npm install OpenZeppelin contracts, we can check in our package.json that we successfully installed this dependency, OpenZeppelin, and now we can use the import. So this is a cursor bug. So let's try to import another time. Okay. Now we don't have the error anymore. So basically we installed the OpenZeppelin library using npm install OpenZeppelin contract. And now we can use this dependency in our smart contract. So we can basically use the OpenZeppelin libraries. How we are using this library? Using basically the IRC20 interface. So here, we are interacting with the IRC20 interface, in particular with the USDC address, calling the transfer from, transferring some tokens, some USDC tokens, from the donor to the campaign smart contract. Any question on OpenZeppelin, RC20, whatever? No? Is it clear? Okay. So, what time is it? Okay. I think 10 minutes and we can have a break. Okay, 10 minutes. So, we have the initialization function. So, initialize the campaign when deploying the smart contract. We have the create campaign that is basically the same function called by the initialization, but it can be used if we want to create a campaign later. So we deploy it first without creating a campaign, and then we can create a campaign with this function. We have a function to post the campaign, and we have a function to donate to the campaign. Now, let's see if our campaign status makes sense at this point, okay? So, isInitialized has been used here in the underscore create campaign to be sure that we create just one and only one campaign for each smart contract campaign. isPost is a status, is a Boolean parameter that can be set as true here in the post campaign, and also is used here in the donate function to check that the campaign has not been paused in order to donate. So it's okay. Then isActive. isActive has been used here in the post campaign to be sure that we can pause only campaigns that has been started. And also we are using the isActive status here in the donate function to check that that we basically donate only to active campaigns, but we didn't define when a campaign turns as active. Okay, we said at the beginning that this is crucial because we want that our campaign will be active only when the CP start is reached. Okay, but we didn't write this logic. So we have to write this logic right now. How can we set basically the isActive as true?
So we can wait for a specific timestamp, or we can just send some, how to say it, send a transaction to the smartphone?
Yeah, so you are completely right. So the true alternative, so the second one is to just have a function that maybe is called setActive, something like this, only admin, and then isActive true. This is a way to do it. A more elegant way to do it is to embed this logic within the donate function. Okay, so what does it mean? It means that we can put here an if condition. So if if the campaign is not active. So if the campaign is not active, or maybe if the CP start is greater than the block timestamp, so basically our start time is reached, this active is set as true. Okay, we can have, does it make sense for you? So basically here, every time that a donation, that a donor tries to donate something, we check if the CP start is greater than the block timestamp, so we set is active as true. One thing missing here is that we need to have CP start greater than the block timestamp, but also that is not already activate. Okay?
So the owner would activate it before CP start with the function set active?
No, we at this point we can maintain this function so that the admin can set as true. But if we put this logic here, at this point we can delete this function. So automatically, without any admin interaction, automatically we can be sure that donations happen only if the CP start is greater than the block timestamp. Okay?
So are you checking either one, like time, or if it's active?
No, it's an and.
Both?
Yeah, both.
Okay.
Both together.
So if the admin forgets to start it and the time is, it will not be active, right?
Yeah, so basically we don't have, right now, we don't have any logic for the admin to activate the campaign. So the only logic to activate the campaign is this one.
And then, but you're going to implement it later?
No, we can't. We can have only this logic if we want. We don't need an admin function to activate it. Do you have any reason why we should?
It's safer for us.
Why?
I mean, you're repeating the start. I mean, if you already put in a start time, it doesn't really make sense to have an active field, right? I mean, just
Yeah.
the start time should be enough, right?
Yeah. We can if we want, we can delete this condition here, these Boolean parameters, and or maybe we can delete this, maintain this one, the CP start, and just check that CP start as a requirement. Yeah, we can do it. Let's do it. So.
It makes sense in other things, but for a donation, not really. But for other kind of, for a token sale or something, yeah, but I will say for this, it's not necessary, right?
Yeah. So we can have this condition. Campaign has not started. So in this way, we are sure that we can donate only if the start has been reached, basically.
Does it happen anytime? Because I cannot read from here. Because it should check, like, if it's before, after start and before the end, right?
Yeah. So we can put it.
Should check for both of those, right?
Yeah.
I'm sorry, I'm a bit short-sighted. So
No. It's okay. So here the requirements are amount greater than 0, start is reached, end is not reached. We can delete the is active. The campaign should not be paused by the admin, and also we have this requirement that we need to actually transfer USDC token from the donors to the campaign contract. Any questions? I change also this requirement here.
Is it possible to somehow create like for example in other languages, I don't know whether you could do it in Solidity, you could create like a getter function that would have this CP start greater than block timestamp as, for example, some kind of active condition, and then you can just change it there. And because if the condition would change now, we would have to modify the code in different places, but then it would be just like in this one place.
Yeah, we can define basically a view function that returns maybe true or false if the condition is true or false. So, for example, if the block timestamp is greater than the start, or maybe we can write a view function that returns, I don't know, how many was the time missing for the start time, whatever. Yeah, we can do that.
I mean, can you create just a modifier like?
Yeah, we can create also. Yeah.
Add it to your
Yeah. We can create a modifier that is only started campaign, for example. Yeah. Guys, if you don't have any question, let's take a break, and then we will start in 10 minutes, 15 minutes maybe, 15 minutes. Okay? Okay, so we have 1 hour, 1 hour and a half for completing everything, basically. So we have our campaign contract with some function to create a campaign, pause a campaign. We have a function for donors to donate to the campaign. So now we have some things missing here that we have to add in order to complete the base logic, let's say, of the campaign contract. Okay, so the first thing that is missing right now is the constructor. Do you know what is a constructor? Okay, so the constructor is basically a keyword in Solidity that can be used to initialize a smart contract when we deploy a smart contract manually. Okay, manually means that we are deploying a smart contract without a factory. Okay, so right now we created the init function that is going to be used by the factory contract that we have to write in order to deploy multiple contracts of the same campaign contract, initializing it with different parameters according to the campaign. But just for completeness, let's say, we can have also a constructor. You just need to write constructor, and we can basically initialize in the constructor in the same way that we made for the init function, okay? Now I will explain. So as the init function, this function will call the create campaign. Okay, what does it mean? Okay, it means that if we deploy this contract manually, we are going to use the constructor. If this contract will be deployed by a factory, the factory will use the init function. So basically, we have a double choice here. Okay. So in this way, our contract is compatible both for a standard deployment and for a factory deployment and its initialization. Okay. Okay. Now, let's complete the donate part. Okay. So we write all our conditions. We write the transfer from of USDC from the donor to the campaign contract. Okay, now I want to implement a nearc 1155. Do you know what is a nearc 1155? We can go to OpenZeppelin. The ERC1155 is another standard similar to the ERC20. Okay, the difference between an ERC20 token and an ERC1155 is that within the same ERC1155 we can create different ID, and then each ID will have its supply. Okay, so an ERC20 is a contract where we have a token address, that is the ERC20 token contract address, and the ERC20 will have a supply of tokens. With the ERC1155, we can define the same contract, different ID, and then each ID has its own supply. Okay? So, what I want to do right now is that every time I make a donation here, I receive back an ERC1155. Okay, that basically will represent my donation. Okay, so that I can later maybe sell my ERC1155 in a, for example, on OpenSea or another NFT marketplace. I can transfer, I can trade, whatever. Okay. So, how can we implement an ERC1155 in our campaign contract? It's super easy. So, the only thing that we have to do is write this thing. Contract campaign is ERC1155. Okay, and we have to import, of course, the ERC1155 from OpenZeppelin, as explained before for the ERC20. Okay. What happens here, and what is the difference between using the interface for the ERC20 or implementing the entire ERC1155 logic? Okay, if we use the interface, okay, we can interact with any ERC20 contract by specifying what is the token address that we want to interact with. Okay, so in this case, I'm using the ERC20 interface, passing the USDC address to interact with USDC on base. That's it. Okay. While if I implement the ERC1155 logic in this way, writing is, it means that this contract, so the campaign contract, will inherit all the logic of an ERC1155 contract. Okay. So this is the implementation. It's not just an interface. It's the actual implementation of an ERC1155. And we can check on OpenZeppelin how an ERC1155 works and what are the functions that this standard exposes, basically. Okay? So ERC1155 is a novel token standard that aims to take the best from previous standard to create a fungibility agnostic and gas efficient token standard. Okay? The distinctive feature of ERC1155 is that it uses a single smart contract to represent multiple tokens at once. Basically, each token within the ERC1155 will have its unique identifier, its unique ID. Okay? And so when we want to interact with a specific ID of a 1155 contract, we have to define the ID, basically. Okay? So writing this, so campaign is 1155, it means that we are implementing in our campaign contract all the base logic that can offer the ERC1155. Okay, so for example, the mint, sorry. If we go to API, we can see all the functions. So, for example, the balance of batch, set approval, safe transfer from, safe batch transfer from, and so on. Okay? And also, okay, and also internal and private functions of the ERC1155 contract. Okay. So let's make an example. Now my campaign contract is an 1155 contract. It means that I can access the function of the ERC1155. So for example, the underscore mint function of the ERC1155, or the balance of batch, and so on. So if you see carefully, this function, so the underscore mint, the balance of, are not functions that I define here in my contract campaign, but are inherited by the ERC1155 contract. Okay? How we will use the ERC1155? So, for example, when a donor makes a donation here, I can mint to the donor an amount of my ERC1155, okay, using the underscore mint. Because if we take a look at how the underscore mint function works, underscore mint creates amount tokens of token type ID and assigns them to 2. So basically it sends the tokens to the to address. Okay. So in our code we will implement this function in this way. So the to address is the message sender, so the donor. The ID, we can use the ID1. The amount is equals to the amount donated by the donor. And then this is an extra parameter data that can be passed as empty, or we can use for basically custom mint logic, okay? But in this case, it's not needed. So for example, let's take an example. If we want to mint a token, we can use the underscore mint. But then if we want to execute another logic, we can put this logic as a bytes parameter here, okay? So of course this is for advanced implementation. In this case, for us, it's not needed. So we will just mint an 1155 token to the message sender of ED1. So we will use only the ED1 equals to the amount. So basically what happens that the donor will send USDC and he will receive an amount of our ERC1155. Okay? Super simple. Now, you will understand better why we can use this approach of basically implement an 1155, because now we write the withdraw function, okay? Okay, the withdraw function is used by a donor to withdraw the USDC that they donated, okay? So, for example, they donated to a campaign, but then, I don't know, something happens, so we have a news that the admin of a campaign is a scammer, what else? Or maybe you changed your idea, you don't want to donate anymore, so you want your money back. So we need a withdraw function.
Like after implementing the ERC 115, I have an error that no arguments passed to the base constructor.
Yeah, something for later. For us, it's okay.
Okay. Yeah, but it has marked my whole code as red.
So the error that you get means that the 1155 token contract needs some parameters in the constructor. Okay? Okay, so if we take, for example, this line of code and we put it in our constructor, you should not have the error anymore. So go to the OpenZeppelin doc and copy this line of code. It's okay? Okay. I will explain later what does it mean. So, withdraw function. This function can be used by a donor to withdraw their money, okay? So, we need to specify an amount of tokens to withdraw, that is amount, okay? We need, of course, that this amount is greater than 0. Okay. Okay, then here, what we can do depends on our business logic, because, for example, we can decide that donors can withdraw money only if the campaign is not ended, or maybe only if the campaign is ended, whatever. Okay, depends on us. Okay. So, for example, in this case, let's make the withdraw available only if the campaign is not ended. Okay. So, for example, CP end is less than, this is wrong, only if the CP end is greater than the block timestamp, okay? So if our block timestamp is less than the CP end, we can still withdraw the donation, okay? How it works? So, we need for sure to send back USDC. Okay, so as made before, we can write IRC20 of USDC address dot transfer to message sender of amount. Okay, in this case we don't use the transfer from because it's the contract itself that will call this transfer function. So it's not a third-party address. Okay. So in the donate function, in this function here is the contract, so is the campaign contract, the message sender of this function, okay? While the donor is the message sender of this function, okay? Because this transfer from is an internal logic, is a logic executed internally in this donate function, okay? So the message sender, the donate function is the message sender, so the donor, basically. The message sender of this transfer from is the campaign contract, because it's this contract, this function on this contract that will call the transfer from. So in this case, we need the transfer from because we need the donors to approve this amount of token to spend, okay? While in the withdraw is the campaign contract, the message sender of the transfer, and is the campaign contract the holder of the USDC token, okay? Because the USDC are inside the contract at this point if we are calling withdraw. Okay. So in this case, we don't need an approve, basically. We can just simply call transfer. Okay, we are basically sending back the amount of token, but before we need to burn the ERC1155 of the message sender, okay? So I will put a require that will go something like this. So what is the logic here? The logic is if this requirement is okay, it means that the message sender has enough token to be burned, okay? So if this requirement is okay, then we can transfer USDC. If this burn fail, it means, for example, that the message sender has not enough 1155 tokens, okay? So basically, it means that the address calling this withdraw function is an address that has not donated before, basically. Because if he donated before, he will have an amount of 1155 minted here. Or he transferred to another address. So he can't no longer withdraw the money, because the new holder will be able to withdraw the money.
And how about if he donated, for example, $1,000 and he wants to withdraw 2,000?
He can do it, because in this case, he can pass an amount, for example, 100, and this code will burn 100 1155. So the token, the address will still have 900, for example, 1155. So it can be used also for partial withdrawal. Okay. The other reason why it's cool to manage position using 1155 is that in this way we don't have to track how many money the campaign raised. Because why? Because the balance of USDC address of the campaign contract will automatically be the total money raised by the campaign. Okay, and on the other side, we don't have to track how many. We don't have to track what each donor donated. Okay, because it is represented by an amount of 1155. Because the alternative, if we don't use an 1155, we have to track in the storage. We need to track each address how much he donated. Okay? In this way, we can skip basically this logic, because we can be sure that if the address has enough 1155, it means that he previously donated at least that amount. Is it clear? Yes? Okay. So we have the donate logic, we have the withdraw logic, we have the create campaign logic. So one big thing that is missing right now is the claim that the admin can do if the campaign has been success. Okay, so for example, if the goal has been reached, so the goal set by the admin, that is CP target amount, has been reached and the campaign has ended, so the admin should be able to withdraw the money. Okay, so we need to create basically another function that is an admin function, so I put here after the pose, that is claim. So function claim, that is external because it will be called by the admin address. So this is an only admin function, of course, because only the admin can claim the money of its campaign. And we need some requirements, because the first requirement that we need is that the block timestamp is greater than the CP end, so the campaign is finished. And also that the IRC20 USDC address, balance of address this, so the balance of the campaign contract is greater than the CP target amount. Otherwise, we will have an error that is campaign has not reached target amount.
So if they will not reach the target after the CP end, what happens?
That donors can withdraw the money. Because we are trying to replicate the same logic of Kickstarter. Kickstarter works in the same way. So if a campaign doesn't reach the target, then all the donors can withdraw the money from the campaign.
Should add more like to withdraw function?
Yeah. So let's finish the claim first, and then we will modify the withdraw. So the claim. Campaign should be end, and the balance of USDC address of the campaign token of the campaign contract must be greater or equals to the CP target amount. In this case, we can transfer the money to the CP admin address. Okay. So here, instead of transferring, for example, the CP target amount, we can simply transfer all the balance. Okay, so this balance here, because, so why? Because if, for example, some wallet or some address for a mistake sends some USDC token to this contract without calling the donate function, what happens is that we will have some USDC blocked basically forever in this smart contract. Okay? While if we use the balance of, we can be sure that the CP admin can withdraw all the USDC amount, even if it was transferred for a mistake or whatever from external addresses. So in the best case scenario, the CP admin will receive more money than the target. Okay? Or in the normal scenario, let's say, this balance of will be equal to the CP target amount. Okay. Let's see one thing. Okay, at this point, we can set the isEnded variable as true. Okay. And so here in the donate, let's add another condition that the campaign is not ended, because this is ended, will be set as true only if the claim was made by the CP admin, okay? So it means that if is ended, we are sure that no more donations. This can be also maybe is a duplicate because we have already this condition, but yeah, just to be sure we can have this condition too. So now we can create campaign, post campaign, claim successful campaigns, donate to campaign, withdraw from a campaign, and that's it. So let's modify a little bit the withdraw logic so that if the campaign doesn't reach the target, the donors can withdraw their money. Okay? So we can do basically in two different things. One is to create another function that is something like withdraw, let's say, withdraw not finished campaign or whatever. Or we can modify a little bit the withdraw function. Okay, so the withdraw function requirements are amount greater than 0. CP end must be greater than the block timestamp. Require burn. And also we can create a condition that I'm thinking, sorry guys. I'm trying to find the best way to do it. So
it should work as well for the donator to withdraw this money he spent before. Like you want to use this function also to withdraw the money by the donator.
yeah, this is for donors only. Okay. So this is donors only. The claim is for the admin. Okay. So what happens if okay, we can create a condition that is so CP start must be no, it's not here. It's in the withdraw. Sorry. So the CP end must be greater than the block timestamp. So we can withdraw basically only if the campaigns reach its end, or if the CP end is less than the block timestamp, so if the campaign is running basically. No, it doesn't work in this way. So we need a way to basically say if the campaign is ended and so and the amount, the goal amount is not reached, we can withdraw. Okay, so the best way to do it is this one. Because with this condition, we are saying we can withdraw money only if the campaign has reached the end, okay? Or the campaign has not reached the end, and the campaign is not ended, and is ended is defined in the claim function, and is ended is set only if the goal is reached. Does it make sense?
But like, but this flag is ended. It doesn't update automatically. Like it would have to do this. Like I think it would be possible that the donations could like, be. Let's say that the some donor could withdraw the money after it has been raised, but not yet collected by the creator.
That's a good point. How can we fix this?
We have to check whether the...
You have to check. So we can check, for example, using a view function that returns true or false if the money are enough compared to the goal.
Or in the donate function, we could say we could set some flag that it was raised fully, because I think checking this every time would be less efficient than storing the result.
Okay, so you are suggesting to basically check here if the balance of the contract is greater than the target.
Because we're not storing the current amount of the...
No. We can use the balance of.
I'm thinking what would be more efficient in terms of...
So probably the most efficient way here is to check here in the donate. Because what we can do is, after the mint, okay, we can have something like this. That can be an internal function. That is something like this. So if the IRC20 USDC address balance of address this is greater than the CP target amount, we can have a not is ended in this case, but something like goal reached, for example, that can be set as true. And we can store a goal reached Boolean here value that will be false by default.
Also,
Yeah.
Could we just store the state of the campaign not as a set of bools, but
Yeah,
as
that's
a
status
value?
as an enum. Yeah. We can do as an enum if you want. So in this case, goal reach will be true. And here, goal reached, and we can basically delete the isEnded parameter because it's no more needed at this point. So what we did, we created a Boolean value that is goal reached, that will be false by default and will be set to true only if after a donation the goal is reached. So the balance of USDC of this contract is greater than the target amount that we set. Okay. If so, we set goal reached as true. And we use these parameters to make a check on the withdraw functions. so that, in this case, the withdraw function can be used in two different ways. The first one is if the campaign has not ended. Okay, so the CP end is greater than the current block timestamp. Or we can use the withdraw if the campaign is ended and the goal has not been reached. Okay?
Should we then change CPN time for a current timestamp if the goal is reached?
No. Why? This is basically the condition that you suggested before. So in this way, we can use the withdraw function in two different ways. Both for withdrawing during the campaign or after if the goal was not reached by the campaign.
Also in the claim method, we can, I think, change this logic of checking the balance could be simplified to checking this bool value.
You mean here?
Because here, when the goal is
Yeah, we can use right now this boolean here instead of calling, because this is gas expensive. Okay. So the claim can be done only if the goal is reached, and in this way, in this case, we will transfer the entire balance of USDC to the CP admin. So let's create a comment here.
So what will happen when the goal reached will be before CPN, and here in require is that CPN has to be smaller than block timestamp. So we can, the owner can't claim before the end?
No. This is the same thing of Kickstarter, for example. So in this way, in this case, this one. So the goal was 93K, and the campaign received 1 million and so on. Okay? But the campaign has 3 hours left. So the campaign is running, even if the amount collected is greater than the goal reached. The difference is that if the amount collected is not greater than the amount reached, the admin can't withdraw, can't claim the money, basically. So it's all or nothing.
But if it's greater, he has to also wait till the end of the time of
Yeah,
the race.
yeah. Yeah, one thing is the campaign end. The campaign end is used to claim, okay? But the claim can only be done if the goal is reached. Okay, so I think we finished basically the logic of our campaign contract. Let's see. So we have a campaign that we can initialize in 2 different ways. One is using the constructors on deploying the contract in a standard way. The second one is deploying the contract using a factory. Then the admin, then we can create a campaign. This should be an only admin function. The admin can also post the campaign, and the admin can also claim the campaign, while donors can donate and can withdraw money. Well, these are internal functions. Okay?
So what function should he use to unbox the campaign if he posts campaign?
Okay, that's a good question. So on Kickstarter, if you delete a campaign, that is basically our pose, then the admin can't restart the campaign another time. Okay. If we want to have a more flexible logic, we can create, we can pass basically a Boolean value here, this way, so that it can be true or false, and the variable will be true or false. But in this case, I will suggest to maintain this simple logic. Okay, so we basically finished the campaign contract. Now, for the first time, let's try to compile the contract. Okay, so npxr.compile. And we have one error. So we have, okay, this is a warning on the campaign factory. Yeah, this is the campaign factory. So we can avoid this warning. CP factory, and for the moment it is an empty contract. Okay, and right now we have only one error, that is the requirement at line 72. That is this burn. While, because probably the burn function of OpenZeppelin doesn't return a Boolean value. So let's check. It doesn't specify it, so let's try. Okay. So basically here, the burn function implemented by, developed by OpenZeppelin doesn't return a true-false. Okay. It simply reverts if the underscore burn can't be done. Okay. So in this way, we can't use a requirement, because a requirement requires that the result is true or false. In this way, if the burn can't be done, because, for example, the message sender doesn't have enough amount of 1155, the function will revert automatically, without our requirement, basically. Okay? So, we successfully compile our contract. Let's do it another time, just to be sure. Okay, perfect. So, it means that our contract compiles. Okay. So, at least grammatically, let's say, following the solidity guidelines, the contract is correct. Okay. Even if the compilation is successful, it doesn't mean that the contract is correct. So the actual logic that we brought inside the contract is correct. Okay, maybe there are some bugs. Okay, but at least the compilation is okay. So there are no formal errors, let's say. So for example, I don't know, if I cancel this amount parameter and I try to compile, I will have an error here. So this means compilation errors. Okay. Now, we have basically our campaign contract that is finished. Okay, that is also an 1155 token contract. So now we have to finish, or we have to start maybe, the factory contract. So this factory contract will be able to deploy clones of the campaign contract. So imagine the flow on the application. So you are here on Kickstarter. I don't know where I can create a new campaign, but let's think we are in the Create tab. Okay, I click Create, and what happens under the hood is that my factory contract will deploy a new clone of the campaign, initialized with my parameters, so my admin address, my goal to reach, and so on. Okay, it's clear? Perfect. So let's write this factory contract. So even in this case, we use OpenZeppelin standards. In particular, we are going to use the clones library. Okay, let's read this text. So there is an import, of course, is a standard. APE1167 is a standard for deploying minimal proxy contract, also known as clones, to simply and cheaply clone contract functionality in an immutable way. Blah blah blah. This standard specifies minimal bytecode implementation. Okay, so basically, if we use this library, our factory will be able to clone our campaign contract. How it works under the hood is quite complex, but we can simplify. So this clones library, basically, every time that we call the clone function, this one, it wants an implementation address as input that, in our case, will be our campaign contract. Okay, and it will deploy a minimal proxy contract, it's called. Okay, a minimal proxy contract is basically a contract that can replicate in some way the logic of our implementation contract, so our campaign contract. How it works, and this is a low level, it makes delegate calls. Okay, so each time we call the clone function and we are deploying a new clone, really we are deploying a minimal proxy contract that points to the implementation contract. This is our actual campaign contract. In this way, each minimal proxy contract can make delegate call to the implementation contract and store and basically use the storage of its minimal proxy contract. So what happens is that we will have an implementation contract, this is the campaign contract that we have to deploy. Once we have the address of our implementation contract, we put the implementation contract address in this function clone of our factory, and this clone function will deploy a minimal proxy contract every time that is called. And each minimal proxy contract, we will use the logic of our implementation contract with its own storage. Okay? So the result is that we can have multiple clones of the campaign contract where each clone has its own storage variables, but the logic is shared because the logic is the one defined by the implementation contract. Is it clear? This is a complex approach, let's say. But if we implement it, it's super easy because the only thing that we have to do is basically to import our campaign contract. So I import from the contracts folder, and I import the campaign.sol contract. And also, I need to import the, let's take this one. I need to import the clones library of OpenZeppelin. Okay? In this way, my CP factory contract will know the functions to interact with the campaign contract and with the clones library. Okay? So, let's start. First thing, we need a constructor because we need to deploy this factory contract and we need to initialize this factory contract with the implementation campaign address. Okay? We can store this address in the storage and we can initialize this variable in the constructor. Okay. Okay. So basically, we will deploy first the campaign contract, and then we will pass the address of the campaign contract here in the implementation, in the constructor. Okay. Once we have the implementation address, we can write the create CP function that is an external function okay. What's the logic that we need within our create CP function? We need all the parameters that the init function wants. Okay, so basically we can copy all these parameters here. Okay. And then the suggestion is good because a new campaign will be the result of the cloning of the factory. How can we clone? We just need to use the clone function of the clones library, okay? So with just one line of code, so address new CP equals to clones.clone implementation CP, the result is that we are creating new campaign contract. Okay? So every time we call this function create campaign, a new smart contract, a new campaign smart contract will be deployed. A new clone of the campaign contract will be deployed. But of course, we need to initialize the campaign contract because if you remember, we write this init function for factory initialization. So what we have to do within the create CP function of the factory is just this. So we access the campaign contract from our import. Okay, we pass the address of the new deployed, the new cloned campaign, that is new CP, and on the campaign contract we call the init function. Okay, what are the parameters that we pass to the init function? This one. I think it's okay, but it's just Okay.
Maybe it's a string memory.
No, we.
You have address and types of the variables.
The types in the function invocation.
It should be only names.
Dot name.
Just need to call it.
Right.
Ah, yeah, sure. Yeah. You are right. So, right now we are passing the parameters needed for the campaign contract to be correctly initialized. Okay, now something that we can polish a little bit. So the first thing is that if we want to be sure that every time an admin creates a campaign using only USDC address on base, we can define the USDC address as of USDC address as the actual base USDC address. So if I go to Basecamp, USDC, this is the base USDC address. I put as a constant the USDC address, and here I don't pass dynamically the USDC address, but I take it from the storage. Okay? In this way, we can be sure that each campaign is correctly initialized using only USDC on base. Okay? Then, another thing that maybe we want to do is to emit an event here. So after we clone a new campaign and after we initialize a new campaign, maybe we want to emit an event. How can we emit an event? We have to define an event in the smart contract. Okay, and maybe in our event we want to emit not only the new cloned campaign smart contract address, but maybe also the CP admin that created that campaign. Okay, so we can do this thing. Do you have any question on this factory approach? So basically what we have to do, or maybe what we did, is we created a new contract called CP Factory. This contract import the campaign contract and the OpenZeppelin clones library. No, I don't want this. Turn off, okay. We define a contract, and then we have a constructor that is used to initialize the factory, setting the implementation contract as the campaign contract address that we will deploy. And then we simply have a function that is create campaign that clones the implementation contract, that is the campaign contract, and then initialize the campaign, the newly created campaign, and emit an event. Is everything clear? So in this way, we can have basically multiple campaigns contract, one for each campaign created on our Kickstarter-like application. So the admin that creates the campaign will interact with the factory to create the contract, the campaign contract, and then we will he will interact with its cloned campaign contract in order to manage it, so to pause, claim, whatever. So let's try to compile another time. So every time you type npxr.compile, you are compiling all the contracts within the contracts folder. Okay, compilation is good. Okay. So the last thing we have to finish. So the last thing that I want to do with you is to try to deploy the factory.
Only with this inherited constructor that you showed me, what is this basic JSON file that is in the documentation okay, or do we have to change it? Because I just copied pasted, but
So basically this one. So this is the URL of the metadata of the RC1155 token.
okay,
So in this case, of course, this is an example, so probably this will be empty or maybe it doesn't exist, whatever. So, but in our case, of course, when we deploy in production, we need to pass here an URL pointing to an existing metadata of the token.
So it doesn't have to be real for the contract
No,
to
no.
be valid.
Yeah, exactly. The important is that a string, just a string. I can be even like this. Okay. So because this is the metadata of the 1155. Okay. And then we have the metadata of the campaign, so it's different. Okay. Maybe this one will be empty because we don't need it. But of course we need the campaign metadata. Okay. So now, just to visualize what happens, let's go on Remix. Do you know Remix? Is a web tool to compile and deploy contracts, basically, from a UI. So it's super simple. So here I already add a Warsaw factory, that is this one. So copy and paste is super simple. Che vuole?
Because the name of the file is different.
Yeah, but
Third line.
yeah, sure. So this will be Warsaw. Okay. Okay, and we need to change this one. So, okay. If I go here, Solidity compiler, so I can select a contract, in this case the factory. No, let's select the campaign, because the flow is we deploy first the campaign and then we deploy the factory. Okay, so let's select the campaign, go to Solidity compiler, click on compile. Okay, the compile is good. So this compilation is the same of our .compile of this one. Okay, it's exactly the same. So once we compile the contract, we can go to deploy. Let's modify something, one sec, because no, it's okay, okay. So let's let's deploy the contract, okay? This is the campaign contract, okay? And we will deploy it with, let's deploy it without the constructor, okay? Because as I said before, this is a double choice, because if we have both the constructor and an init function, it means that this contract can be deployed and initialized both by a factory and manually, okay? But in this case, we don't need the constructor, because this campaign contract will be just our implementation contract. So it should be deployed without any storage variables. It should be empty, because then it will be initialized every time by the factory. Okay, so let's remove right now.
I don't think you can remove it because it's an ERC 1155.
Yeah, I just removed this,
Okay.
the parameters. I'll maintain the 1155, okay? Okay, in this case, as you saw, it changed because now the deploy doesn't need any parameters, any input parameter, because this deploy here is the standard deployment, and the standard deployment uses the constructor, okay? So let's open MetaMask. I'm on Sepolia. Let's click on injected provider MetaMask. In this way, Remix will be connected to my MetaMask, and so to Sepolia. This is my address. Let's click. Perché non mi connetto 0x0? Some bugs. Here, connect account. Okay, perfect. So, contract, Warsaw factory, Warsaw campaign, compilation, deployment, injected provider. Okay, right now we are connected with this wallet, 0x06 and so on, one hit, and we have one hit on Sepolia. Let's click on deploy. This will deploy basically our campaign contract. That is our implementation contract for our factory. Okay, we successfully deployed the contract. Let's wait a little bit that the Sepolia ethers can show me the result of the transaction. Perfect. So this transaction was made from this address, that is my wallet address here. And the result is the creation of this contract. Okay, this will be the address of my campaign implementation contract. Okay, so I copy this address here. Let's go back to Remix. Let's take this time the factory. Let's compile the factory, and let's deploy the factory, passing as implementation campaign address the newly deployed campaign contract. Okay, so this is the contract that I deployed 2 minutes ago. Let's click on transact. So now I'm deploying and initializing the factory. Let's see. Okay. So this is the transaction made from my wallet, this one, to this address that is basically the newly created factory contract. So as you can see, this is the address of the factory, this is the address of the campaign implementation contract, and are different. Now we have both the factory and the campaign contract. Now we can use the factory to clone the campaign contract. Okay? So what we have to do is going here, these are the contract deployed. Let's go to the CP factory, and I have this function that I can call, that is the create CP function. This function, I remember you, that can clone the campaign contract. Okay, so for example, let's imagine that this is the interface of our Kickstarter-like application. Okay, we are on a tab where I'm setting my campaign parameters. Okay, this. Okay, so I put all the parameters, and then when I create the campaign, under the hood, I'm cloning the campaign factory and deploying my campaign contract. Okay, so I need the CP admin, that is my address, let's say, some metadata that can be, ciao. Tomorrow we will create some campaigns with real metadata. Okay. CP target amount is expressed in USDC. USDC has 6 decimal, so it means that to say 1 USDC, we have to write 1 with 6 0. 1, 2, 3, 4, 5, 6. So this is 1 USDC. Okay, let's create our campaign with a target of 1,000 USDC. So this is 1, this is 10, 100, 1,000. Okay, this is 1,000 USDC. CP start. So CP start Unix timestamp. So let's say that I want to create so we have this Unix timestamp as the start time. That is basically in 1 hour, and we have an end time that is in 1 month. Sorry. Okay. Now, if everything works fine, now I click this button, and I'm cloning the campaign implementation contract, and I will initialize this clone with these parameters. So the transaction was good. And in the logs, that are basically the events, I have this one that should be my cloned campaign contract. This one. I can see this. I think we need to 60. Let's see.
So this solidity contract would work also on Ethereum and also on Base network?
You mean it will work?
Yeah.
Yeah.
On Base network and Ethereum network?
Yeah. So here, this is the cloning transaction. Okay, so the one that I obtain clicking this button here is this one. Okay, here in the logs, or maybe in the state, I can check this address here. Let's see, this 0x9 and so on, that is this one, that should be the cloned contract address, so the campaign clone contract address. Okay. Now, just to be clearer, I can, for example, I can write here a returns parameter. So, for example, I can return the address of the new CP, that is the clone campaign, within the function, so that I can see in the output what is the clone campaign contract address. Otherwise, I need to verify my contract on Etherscan so that I can check the event clearer, because right now the contract is not verified, so I can't see the logs, so the events in a human readable version, basically. Okay, so we need to verify the contract or to put a return statement here so that we can read the return statement, or otherwise we can check the contract in the as I did in the state change that is more complex.
And how to verify the contract?
So we can verify the contract directly on Etherscan. So, for example, this is the factory contract. Okay, if I click here and if I go to contract, it says, "Are you the contract creator? Verify and publish your contract source code today." Okay. If I click here, there is a procedure that I can make in order to verify the contract, or I can use a plugin for RDAT. Okay, that is a little bit complex, but I can verify directly through RDAT.
So if the contract is not verified, we should be like 99% sure that it is a scam? Or
Yeah, you should verify the contract, of course. It's better to verify the contract, because otherwise you can check only the bytecode of the contract. Now, the final test is taking this address, that is our clone contract address, load this contract address here in Remix, and check if the parameters are initialized correctly. Okay, how can I do it? So I should select Warsaw campaign, so the campaign contract, compile the contract, go to deployment, and instead of transact to deploy another time, I can paste the address here and click on load here at address. Some months ago it was load contract, now is at address, and as you can see, I load this contract here, so I can interact with a contract. Now I can see that CPN is initialized as with the same parameters that I passed when cloning the contract to the factory. Same thing for the metadata, CP start, target, and goal reach, of course, is false. The address admin is mine admin address. So it means that right now we successfully cloned the campaign contract, and being the admin, I'm the admin of this campaign, I can start interacting with the contract, and donors can start to donate to this contract. So that's pretty much it. This should be the end of our campus lesson. Thank you.